Hello everyone, welcome back to my organic chemistry mini lecture. Today our topic will be aldol condensation. This condensation includes two reactions. First step is aldol reaction, and the second step is dehydration. The first step, aldol reaction, is the self-condensation of aldehyde or ketone and under basic condition or acidic condition. This example shows basic condition. I will show the acidic condition mechanism. And the intermediate here is called aldol product. So why it's called aldol? Aldehyde, alcohol is called aldol. Of course, if this is ketone, it's also called aldol product. And then second step, dehydration, will lose one water, form a double bond here. And so the overall reaction is called aldol condensation because we will lose one water as small molecule. And the first step is called aldol reaction. Be careful, don't be confused. Okay, I will show you the arrow pushing mechanism under basic condition. First, we have the alpha proton here will be depronate this base hydroxide. And then it will form the intermediate. It's called an enolate. This enolate is a good nucleophile. It will react with another molecule of the starting material. This shows the propanol. This is aldehyde. And then the arrow pushing start from this lone pair of the oxygen and push the pi electron, attack this carbon of this carbonyl, and push the pi electron to the oxygen. That's nucleophilic addition to form this intermediate, which is negative charged on this oxygen. The oxide will be protonated by the water. The electron start from lone pair of the oxygen to the proton, take the proton, push the sigma electron to the oxygen to form the hydroxide. That is the base catalyst. And then this is the protonation, give you this neutral intermediate. It's called aldol product. And then now second step and the basic condition followed a E1CB mechanism. So we know E1, C means conjugate, B means base. So that means it will form a stable conjugate base of this aldol product. So hydroxide will depronate this proton. This is still the alpha proton. And then push the sigma electron to here, form pi bond and break that pi bond to oxygen. And this deprotonation form a stable conjugate base of this aldol product. And you can see the structure is actually enolate, same as this intermediate. And then the second step, the electron from the oxygen push back and push the pi electron to here to form the other pi bond here and kick off this hydroxide as a leaving group. And that's the second step, elimination, form this aldol condensation product. And this is called alpha beta unsaturated aldehyde. Okay, now let's talk about the acidic condition. So we have a proton here now, and the first step is also aldol reaction. And second step, we need to lose one water, dehydration, to form this alpha beta unsaturated ketone, because this time I use acetone as example, not the aldehyde like last slides. They basically follow similar mechanism. Now first step, we have this ketone. This is actually acetone. We have a proton, so protonation is the first step. Start from the oxygen's lone pair to the proton. Protonation give you the activated carbonyl here. And then this alpha proton will be deprotonated by water. Although water is a weak base, but this alpha proton is activated. So take the proton, push the sigma electron to here, form the pi bond, and then break the pi bond. And then that deprotonation give you this neutral intermediate. It's called enol. The enol is a nucleophile. This can attack the other molecule of protonated acetone from the first step. So basically, this is the same as this intermediate. Now this is the electrophile. So this enol is a nucleophile. Electron from oxygen will push back and push the pi electron here to attack this activated carbonyl carbon, and then push the pi electron to the oxygen. Neutralize the positive charge. Then this nucleophile addition give you a protonated intermediate. You can see this is the protonated ketone. And then next step is the proton transfer. This oxygen will take this proton, push the sigma electron back to neutralize this positive charge of oxygen. So proton transfer. And then this hydroxyl group will be converted to water, a much better leaving group. And this will dissociate to form a tertiary carbocation. This alpha proton will be then deprotonated by water, although this is a weak base. But this tertiary carbocation make this elimination much easier. Deprotonate the proton, push the sigma electron to form the pi bond here. And then that elimination is actually E1 mechanism. And then this is the neutral final product. It's another alpha beta unsaturated carbonyl compound. And this time it's ketone. Okay, so this is the aldol condensation under different condition, the apportion mechanism. Now we will talk about a cross aldol condensation. So I will use example of the dibenzyl acetone. So the reactant are different, not self-condensation anymore. This is acetone, this is a benzaldehyde. This pH means phenyl group. I use example of basic condition, and you will form this pretty big conjugate system here. And arrow pushing mechanism. First step, we have the acetone, and we have the alpha proton will be deprotonated by the base. So this is alpha proton, and the base will deprotonate the proton and push the electron back to form the pi bond, and then break that pi bond to oxygen. So deprotonation will give you this enolate intermediate, and this is a good nucleophile. This will react with the benzaldehyde. The electron of the oxygen push back and push the pi electron to attack this carbonyl, and then push the pi electron to the oxygen here and form this intermediate. This oxide will be protonated by water. Basically, the electron from oxygen attack this proton and push the sigma electron to the oxygen. And then protonation will give you the neutral intermediate. This is the aldol product. And then next step, the base will deprotonate this alpha proton. Deprotonation, push the pi electron to here, form the pi bond, and push the pi electron to the oxygen here. And then that deprotonation give you this enolate intermediate. And basically this follow the E1CB mechanism. And next step, this electron of oxygen push back and push this pi electron to here and kick off this leaving group as hydroxide. And that elimination give you aldol product, aldol condensation product. And that's not the final product, because you still have another carbon, and that carbon's alpha proton will be deprotonated by the base. Again, make this enolate the intermediate. This enolate will react with another molecule of benzaldehyde and then push back the electron of the oxygen, push the pi electron to attack this benzaldehyde carbonyl, and then break the pi bond here. And the intermediate will be this oxide here. And then next step will be just the protonation of this oxide, and take the proton, push this sigma electron to the oxygen. You form the neutral intermediate. Again, the base will deprotonate this alpha proton, follow this E1CB mechanism. This will first deprotonate the alpha proton to form this stable conjugate base, which is actually the enolate. And then second step, this lone pair of the oxygen push back, the pi electron will be pushed to here and kick off this hydroxide as a leaving group. So final product is this neutral and with conjugate system here. So that's called a dibenzyl acetone. Okay, last I will talk about intramolecular aldol condensation. So that will form a ring system. So I will use this example as diketone. Okay, this is the 2,3,4,5-2,5-hexane diol. And we use a basic condition, form this 5-membered alpha beta unsaturated ketone. Okay, so the arrow pushing mechanism, first step, we have this diol, and the alpha proton will be deprotonated by the hydroxide. This alpha proton will be deprotonated to form enolate. That's enolate. And this enolate will have intramolecular reaction. So you can see the electron can push back, and this pi electron will be pushed to attack this carbonyl. And then that will push this pi electron to the oxygen to form a 5-membered intermediate. See, this carbon is this carbon. This carbon is this carbon. This oxygen is this oxygen. So this will get protonated by water. Again, the electron from oxygen attack this proton and push the sigma electron to the oxygen to form neutral intermediate. And the next will follow E1CB mechanism. So the base will deprotonate this alpha proton. Hydroxide will take this proton, push this sigma electron back to form the pi bond, and push this pi electron to the oxygen to form the enolate. And then this enolate will do the elimination. So electron push back, and this pi electron push to here and kick off this leaving group as hydroxide. So this is the final product. It's a cyclic alpha beta unsaturated ketone. There's another possibility for this reaction. For example, this is also alpha proton, could potentially be deprotonated by the base to form the enolate, similar intermediate, and the reaction could happen between this carbon and that carbon. So the electron can push back, this pi electron can attack this carbonyl. However, this will form a 3-membered. You can see this intermediate is a cyclopropane intermediate, and although potentially it could get the protonation and followed by E1CB elimination, potentially could form this 3-membered alpha beta unsaturated ketone. However, this ring has too much ring strain, so this possible reaction actually will not happen. Okay, that's all I want to talk about the aldol condensation. So if you have any questions, please let me know. Okay, good luck.